Greetings everybody. This is video 2 for Exam 2 Practice 1. And this is problem 3. And it's a Newton's second law as applied to, in the language of physics, a very common application of Newton's second law called connected masses. You can see M1 in the figure. M1, M2, and M3 are connected by the two strings. One string connects M1 to M2 via a frictionless pulley. The second string connects M2 to M3 via a frictionless pulley. Okay, you know the three masses. You know M1, M2, and M3. And M3 is twice as heavy as M1. So we know pretty much to a very good logical guess that when you release the system from rest, M3 will accelerate downward, M2 will accelerate to the right, and M1 will accelerate upward. Because clearly, see, M3 has twice as much mass as M1. Now, there's friction, you can tell by in this figure, the rough diagram, there's friction between M2 and the table. And that coefficient of friction, kinetic friction, is 0.375. Pulleys are massless and frictionless. We know that, again, that we know about the tensions. So I want to know the acceleration of the masses. Well, because they're connected, they're obviously will have the same acceleration, but I want to include the direction, which we know to a very good, a very logical assumption that, again, M3 will accelerate in the negative y, M2 will accelerate in the positive x, and M1 will accelerate in the positive y. So I want to know what is that acceleration. I want to know what is the tension in each rope. There's going to be a tension in the rope connecting M1 and M2. There's going to be a different tension in the rope connecting M2 and M3. All right, so I want A and T. Well, again, we want to draw all the forces acting on each mass. Clearly, M1 and M3, they are not touching the table. There's a clear gap between M1 and the table and M3 and the table. So for M1 and M3, there is not a normal force. You'd be surprised how many students somehow think there's this magical Fn acting on either 1 or 3. Well, there isn't. The picture's very clear on that. But anyway, so I'm going to draw all the forces acting on M1, all the forces acting on M2, draw all the forces acting on M3. That's the rubric. Draw all the forces acting on each of the masses. In this case, there's 3. Apply Newton's second law to each mass. So I'm going to have to apply Newton's second law 3 times. I have to apply it to M1, I have to apply it to M2, and I have to apply it to M3. So draw in all the forces acting on, or draw all the forces acting on each mass. Apply Newton's second law to each mass. Then do the algebra to solve for the unknowns. In this case, I want the acceleration A, and the two tensions, it'll be a T1 and a T2. Okay, let's go ahead and bring up the answer key. Well, I'm just going to go, again, what I've done first is we know, I think to a good assumption, that M3 will be accelerating in the negative y, as indicated by this A with the dotted arrow. That's not a force. I'm just saying, hey, everybody, M3 is accelerating in the negative y direction. Here, M2 must be accelerating in the positive x. And here, M1 is accelerating in the positive y. So that's the first step. Okay. So now just going left to right, let me draw the forces acting on M1, the forces acting on M2, and the forces acting on M3. Well, for M1, there's the weight, M1G, and the tension force, T1. Those are the only two forces acting on M1. M1G is in the negative y, T1 is in the positive y. We know that M1 is accelerating in the positive y. All right, let's look at M2. Now remember, when there's friction, in this case there's clearly friction between M2 and the table. So if you have friction, you're going to need Fn. So let me go ahead and draw all the forces acting on M2. Well, there's its weight, M2G, drawn as such in the negative y. Fn, it's the normal force of the table on M2, that's in the positive y. Now remember, M1 and M2 are connected by a string via this frictionless pulley. So I know there's going to be a tension force on M2. Remember, tension force is along the string but away from the object. So T1 is the tension force acting on the left side of M2. Notice, how do I know it's T1 and T1? Because this string is connected via a frictionless pulley. Now remember, M2 is accelerating in the positive x. That means Fk in here. Fk is in the negative x. Okay, so right now I have M2G, Fn, T1, Fk. Now let's look at here. There's a string that connects M2 to M3. So now because, and that tension in general, the tension in the left string cannot be the same as the tension in the right string, because in this case the mass separates them. They're not separated, they're not connected via a frictionless pulley. They're two different ropes connecting different masses. So let's call this tension T2. And on the right side of M2, remember the tension force is along the string but away from the object. So I have, those are the 5 forces acting on M2. And remember, in general, those two tensions on the different sides of M2, they cannot be the same because they're not connected via a frictionless pulley. They're physically 2 different ropes. And they're connecting, in this case, one rope is connecting M2 and M3, the other rope is connecting M1 and M2. So, but anyway, so that's that. So there's your, now let's look at M3. Well, again, just like M1, the only forces acting on M3 are the weight, M3G, and the tension force, T2. Well, I know that this tension, the tension on the right of M2, I know that's T2, that's going to be the same because that rope connecting M2 and M3, frictionless pulley, so tensions are going to be the same. Okay, so those are my forces. Now let me apply Newton's second law to each mass. All this means with the colon, I'm saying this is Newton's second law applied to M1. This is Newton's second law applied to M2. This is Newton's second law applied to M3. The M3 colon, M2 colon, M1 colon, they're not part of an equation. That's just my notation of saying, hey, this is Newton's second law as applied to M1. All right, so let's look at M1. Well, it's accelerating in the positive y, and T1 is in the positive y. So we're going to write for M1, it's going to be T1 minus M1G equals M1A, because T1 is positive and M1A is positive, because for M1, A is positive. So the T1 and the M1A, they better be positive, and the M1G is negative. So it's T1 minus M1G equals M1A. That's equation 1. Now let me apply it to M2, but in the x direction. We'll worry about the y direction in a minute. Let me apply Newton's second law to M2, and I'm doing the x direction right now. Well, T2 is positive, T1 and Fk are negative. So I have T2 minus T1 minus Fk. Just look at the diagram. T2 minus T1 minus Fk. But clearly, T2 is positive, T1 and Fk are negative. So that's the sum of the forces. There's 3 of them. What does that sum equal? M2 times A, mass times acceleration. Now we know when I apply Newton's second law to M3, because M3 is accelerating downward, I write it as M3G minus T equals M3A. So I write it as M3G minus T2 equals M3A. So that gives me 3 equations. I'll label them 1, 2, and 3. Now, what about Fk? Let's look at the equation for M2. What about Fk? Well, Fk is always what? Fk is always mu k Fn. Well, what is Fn? Well, look at your figure. Let's look at M2. Clearly, we don't need to make a big song and dance about it. Fn is m2g. Obviously, m2 is not accelerating in the y direction. You just have the positive force and the negative force. So clearly, Fn equals m2g. So Fk is mu k Fn, which is mu k m2g. Let me go ahead and put that in for Fk. So now I have my equations 1, 2, and 3 as follows. And this is the next technique is very common. I'm just going to add equation 1. I'm just going to add the three equations, 1 plus 2 plus 3. What that means is, remember, you have to add left side, add the left side to the left sides, add left to left, and then you have to add right to right. So when we do 1 plus 2 plus 3, we do left plus left plus left must equal right plus right plus right. So when I add the left side, notice I have T1 and minus T1. I have a T1 and a minus T1. They cancel. Then I have a T2 and a minus T2. They cancel. That's not some trick I made up. That's a very standard algebra method. So the tensions on the left-hand side, T1 and T2 cancel. So you have a T1 minus T1, T2 minus T2. I'm left with M3G minus mu k M2G minus M1G. That's what I get when I doing 1 plus 2 plus 3. That's what I get on the left. Now on the right-hand side, I get M1A plus M2A plus M3A, i.e. parentheses M1 plus M2 plus M3. Then close parentheses times A. So I'm calling this equation 4. And again, this is a very standard technique. What I did right there, that's very standard. So I get, again, M3G minus mu k M2G minus M1G equals parentheses M1 plus M2 plus M3 times A. Then I want to solve for A. Just divide both sides by the term in parentheses. So A is simply equal to right here. Basic algebra. Just in equation 4, just divide both sides by the term in parentheses. You know the masses, you know G, and you know mu K. So plug in the numbers, and you get positive 2.57 meters per second squared. Because the acceleration came out positive, we know that our choice of direction, here, here, and here, I know that that choice was correct. And, we're not out to trick you. Typically, it's pretty obvious that because M3 is twice as heavy as M1, when that system is released, they will accelerate as we chose. And because A came out positive, we're correct. So we got A. Now we need T1 and T2. Well, you can use any of, now we know A. So you can use, equation 1 to get T1, and then you can use equation 3 to get T2. That's what I would do. See, from equation 1, solve equation 1 for T1, and you get T1 is just M1 parentheses G plus A. I just solved equation 1 algebraically for T1. Plug in numbers, you get 37.1 newtons. Then I just solved equation 3 for T2. T2 is M3 parentheses G minus A. We know A, the acceleration from part A, and we knew the masses. Plugged in numbers, we get 43.4 newtons. That's it. But again, you want to make sure that you're not confused by what I did in this algebra here. How I got equation 4 when I added equations 1 plus 2 plus 3. Nothing complicated. You just add left left plus left plus left equals right plus right plus right. T1 minus T1, T1 cancels. T2 minus T2, they cancel. You're left with M3G minus mu K M2G minus M1G. Now on the right hand side, you simply have in parentheses M1 plus M2 plus M3 times A. And that gives you your equation 4. Solve, divide each side by the parentheses, that gives you A. Once you know A, equation 1 gives T1, and equation 3 gives T2. I'm going to go ahead and save this video and get it posted.